Hello students, today we are going to discuss about the laws of polarization. In that we will discuss two laws of polarization, that is first one is Malus law and second one is Brewster's law. The difference between these two laws is the Malus law is represent with respect to same medium and the Brewster's law which is represent in terms of transparent medium. So these two laws helps us to know about the nature of polarized light. That means when unpolarized light is passing through the polarizer, then what is the nature of that polarized light we have to discuss by using these two laws. So let's begin with the first law, that is Malus law. See, we already discussed this diagram in case of we already discussed this diagram in case of plane of vibration and plane of polarization. So we are using same diagram to explain the law, that is Malus law. Look at here, this all directed arrows which are represent incident unpolarized light. We already know what is unpolarized light. So when this unpolarized light is passing through the first polarizer, so we are consider, in case of first polarizer, we are consider only a particular wave when this polarizer is used to emerge this unpolarized light, and they can reflect it the emergent plane polarized light. After this plane polarized light is passing through the second polarizer, so this second polarizer is act as an analyzer which can analyze the nature of plane polarized light. And when this even, that is electric field vector of particular wave is passing through the second polarizer, it makes an angle theta. Why? Because we already discussed that when we consider suppose when we consider a second atom or another atom of wave along the x-axis is directed along the x-axis, it is not necessary that electric field may be travel along y-axis and magnetic field will maybe travel along z-axis. They can travel along yz axis in any direction, but this condition is applicable only for second polarizer. Why? When the first polarized light is passing through the second polarizer. So the Malus law is the Malus law is represents the intensity of the plane polarized light, and he discovered that the intensity of the plane polarized light, look at here, the intensity of the plane polarized light is directly proportional to the amplitude of the given wave, and the cos phi is represent phase angle. Why? Because we consider this unpolarized light with respect to electromagnetic wave, and when we consider the term electromagnetic wave, we are consider the phase, right? So now we can start from first point. See, consider an unpolarized light having angular frequency omega and wave vector k. See, the formula to find out wave vector k is 2 pi upon lambda. That lambda is represent wavelength of given wave traveling along x direction. Look at here, this is unpolarized light. This horizontal line is represent x-axis and this vertical is represent y-axis, and z-axis we are represent in this vertical line is represent y and this is represent z, so that perpendicular line is represent yz plane. So the magnitude of its electric field is given by E is equal to E0 sine kx minus omega t. So how it comes the equation? Because we already know that when we consider a progressive wave when traveling from one point to the another point, they represent the displacement, and that displacement we are represent x is equal to r sine omega t. And when we consider a phi, then x is equal to r sine omega t plus phi. But here we are consider electromagnetic waves, that's why we are consider electric as well as magnetic field. So to explain the Malus law, we are consider only electric field. Why? Because we know that magnetic field is perpendicular to the electric field, and here we are considered the unpolarized light is passing through or is traveled through along x-axis only or along x direction only. So we are considered only electric field. So the magnitude of its electric field is E is equal to E0 sine kx minus omega t, where E0 is called amplitude of the wave. See that E0 is represent amplitude of the unpolarized wave or unpolarized light. That's why we wrote E suffix 0. Sine, it's an angle. K is represent wave vector. X is represent displacement of that wave. Omega is represent angular frequency, and T is represent time required for wave to pass from one position to the another position. But we know that the intensity I is directly proportional to the amplitude square. This relation we already discussed in 11th standard chapter number 13, EM waves and communication system. In that we discuss characteristics of EM waves, and in that topic we discuss the first we discuss one of the characteristics of EM wave, that is intensity is directly proportional to the amplitude square, and this amplitude square we are represent different for different field. See, I is proportional to the E0 square, but when we consider in case of electric field, that I is represent IE is equal to half epsilon 0 E0 square, and in terms of magnetic field, IB is proportional to the half B0 square upon mu 0 square. What is half? That the term half we will discuss later. Okay. So the direction of E is anywhere in the YZ plane. They already mentioned that the direction of this electric field vector is anywhere in the YZ plane. We cannot say that the direction of electric field vector is along x direction. No, it is anywhere in the YZ plane. So this first point is related to the unpolarized light only. So now this second point we are consider in terms of particular wave having E1. So let us consider a particular wave having its electric field E at an angle phi. We already know that phi is phase angle phi to the axis of first polarizer. The component E0 cos phi will pass through only, and E0 sin phi will be obstructed. Obstructed means block. Why? Because light does not the light does not travel in backward direction. The backward direction do not exist. That's why the sine E0 sin phi will be obstructed, will be blocked, and we are consider the component we are consider the cos phi components only. Okay. So the intensity of this particular wave, which wave? That single wave. So the intensity of this particular wave will be again I is proportional to the E0 cos phi square. See, here we are not consider phi, but here we are consider a term phi. Why? Because here we are consider unpolarized light. When we consider unpolarized light, the value of phi it changes from 0 to 180 degree. So we cannot say that what is the exact value of phi. But when we consider in case of particular wave, then we will get the particular value of phi. That's why we wrote in case of particular wave, I is proportional to the E0 cos phi the whole square. See, I wrote here for unpolarized light phi having all values from 0 to 180 degree, because this is represent how much? 180 degree, right? Hemisphere. The total angle is 180 degree. So if we find next, see this value, that is I is proportional to E0 cos theta cos phi the whole square. This value is represent for particular wave. But if we have to find out total intensity of the polarized light, then we need to find out average of this E0 cos phi square, and the average of this E0 cos phi square, the average of the cos phi square is nothing but half. The average of this cos square phi is nothing but half. That's why we can write I is proportional to the half E0 square. Here I have to mention two things. Look at here. For first thing is, for electric field we can write I is equal to half E0 square epsilon 0, and that is IE, because we are considering electric field. And second thing, in case of magnetic field, that is IB is equal to uh, half B 0 square upon mu 0. See, in case of electric field, half. Both fields we are represent the term half. So that half is nothing but what? The value of phase angle of the traveling waves along x direction, right? E0 we are considering amplitude for electric field, B0 we are considering amplitude of magnetic field, epsilon 0 and mu 0 are called. Epsilon 0 we are considering permittivity of the given medium with respect to electric field, and mu 0 we are represent permeability of the medium with respect to given field. So this case I is proportional to the half E0 square. This is applicable for first polarizer. So this second points is related to the first polarizer. Now third point is that when we consider linearly polarized wave emerging from first polarizer, that means this first polarizer, when this unpolarized light is passing through this first polarizer, and when this first polarizer is immersed this plane polarized light, so the direction of this E1 we are represent in terms of what? In terms of y-axis. We are always we have considered the term particular direction, but what it's mean? The particular direction means we are considered the vector, that is unit vectors I, j, k. That's why when we consider in case of y-axis, we are considered the unit vector j. So that's why we wrote E1 is equal to j cap. This is represent particular direction of the event. E10 is called amplitude of this emergent wave, again sin kx minus omega t. The reason of this, why we consider j, because E1 is directed along y-axis and E10 is amplitude of polarized wave. Therefore, we can find out the intensity of that emergent wave, which is given by I1 is proportional to the E10 cos phi square. Same thing, just we can say that intensity of emergent wave here, and here we represent intensity of the given wave, and right. So now next again, this emergent wave is passing through the second polarizer. When this emergent wave is passing through the second polarizer, this second polarizer is an act as an analyzer which shows the nature of light, right? So now again, if this wave passing through the second polarizer, it makes an angle theta with y direction. Why it makes an angle theta with y direction? Because when we consider number of atom emits by wave, then we cannot say that the electric field is along y-axis and magnetic field is along z-axis. We can say that both fields are along yz plane in any direction, right? But when we consider the term single atom, then we can say that it's along x-axis, electric field is represent along y-axis and magnetic field is represent along z-axis. But when we consider number of atoms, then we cannot say that the direction of electric and magnetic field. Why? Because they can directed along any of the direction in the yz plane. That's why we can consider the theta in case of E2. And again, intensity of this second emergent wave is represent I2 is equal to E10 cos theta square. See, here I wrote cos phi, but here I wrote cos theta. Why? Because here cos phi is represent phase, but here theta is represent angle of polarization. That's why we can write I2 is proportional to the E10 cos theta square. Instead of this, we can write I1. So I2, because E10 is represent what? I1. So therefore I2 is equal to I1 into cos square theta, and we know that cos square theta is equal to half. Therefore we can write I2 is equal to half I1, and this is called Malus law for polarization. To explain the term, that when the light is linearly polarized, then their total intensity is one half of the given intensity of the light. This is called Malus law of polarization. Okay, thank you.